Welcome back to this video series of C++ programming. This is the lecture 23 of this video series, and today we are going to talk about inheritance in C++ programming. Inheritance is one of the powerful features of C++ programming and which allows you to create or derive one class from another class. Let's see how. A class that is inherited is referred to as a base class, and the class that does inheriting is called as a derived class. That means basically a derived class will hold all the properties of base class from which it is derived. When a class inherits another, the members of the base class becomes members of the derived class. We'll talk about these 3 points with the help of an example. So there we'll understand how we can derive one class from the another class and how we can access the members of a base class as well as a derived class. The third point says a derived class can be used as a base class for another derived class, creating a multiple inheritance. That means when you derive one class, you can create another class and derive that class from the previously derived class. So that will create a multiple inheritance. This way you can derive the multiple classes. We'll talk about this point also with the help of an example. Let's first understand the syntax of the derived classes, how we can derive the class. So you have to specify this class keyword and the name of the class followed with these two colon marks and then the access. So this is very important. So access, as you know, there are three kinds of access specifiers in C++. There is a public, private, and protected. So this access basically refers to them, and then followed with the name of the base class from which this derived class is derived, and then inside uh, it contains the body of class, so different public and private and protected members. The base class access specifier must be either public, private, or protected as we discussed. And if no access specifier is present, the access specifier is private by default. So that means when you don't specify any access specifier here, it will become a private by default. In case of a structure, as you know, you can derive the one structure from another structure. In case of structure, this access specifier is by default public, which is private in case of classes, but in case of structure, it is by default public. So if you don't specify any access specifier, by default, the access specifier with the uh, structures will become a public. Let's understand this access specifier. But before that, let's understand how we can create this base classes and derived classes, or how we can use this inheritance mechanism in C++ programming. For that, here we'll create two classes. One class we'll call this as a base class. So name of this class is a base, and inside this create some private members. So I'll create two variables which are private to this class. Similarly, I will create some public member functions here. First function will set the values for these a and b variables. And another function, it will display those values. Alright, now we'll create another class and we'll call this as a derived. And as we saw before, when you want to create a derived class, you have to specify this colon mark and the access specifier. So we'll specify the access specifier as a public here for now, and then the name of the class from which it is derived. So that is a base class. So in this case, the name of base class is a base. So you have to specify this name here. And now this class called as derived is derived from this base class. That means it can, all the members of this base classes are visible to this derived classes, but access to these members, it depends on this access specifier. So we'll talk about how this members access varies based on this access specifier in this video. Here I'll change the name of the variables, and inside this main function we'll create some object of this classes. First, let's create the object of a base class. How to create object of base class? You have to specify the name of that class and then the name of object. So in this case, B is one object. Now with the help of this object, we can access the members of this base class. So now we can access only the public members of this base class outside this class. So from this main function, we can just access the public members. We call this set value function to set the values, and we'll call this display function to display the values of those member variables. And similarly, we'll create a object for this derived class. So we'll call this as a D. Now with this D, we can have access to the public members of this derived classes. Alright, so we created objects for the base class and derived class, and with the help of these objects we are accessing this public member function. First, let's compile this program and let's run it to see whether it is outputting the values correctly. As you can see, it is outputting the values as a 2, 3 for both these objects. So let's change these values to 4 and 5, and let's again verify the result. And now you can see it is outputting the values as a 4 and 5 for the derived class object. Alright, so our program is working fine. Now in this case, what makes this derived class different? So as we saw, this is access specifiers make some difference. Now in this case, this access specifier is a public. That means all the public members of the base class becomes a public to this derived class. Remember, all the public members of the base class becomes a public member to derived class. That means they can be accessed outside this derived class using the derived class object. So with the help of this D object, we can access this uh, public members of this base class. So here we'll just change the uh, function names so that it will be able to distinguish between these two function names. Alright, so in this case, this set value and display functions, they're actually referring to this base classes functions, and this set value 1 and the display 1 functions are referring to the member functions present in the derived classes. So with the help of this inheritance mechanism, we got the access of this members of the base classes from this inside this derived classes. And since the access specifier is a public, those members become public to this derived class. That means they can be accessed outside this derived class. So from this main function we can access them. Now let's compile this program and let's run it. Now you can see it is outputting the values for this derived classes as a 2, 3 and 4, 5. Now why 2, 3 is because here we are first calling this set value function from base class, and already we have set the values for this a and b member variables as a 2 and 3. So that's why it is outputting the first value as a 2 and 3 for this derived class object, and then these two functions, or rather this display function, is displaying the output as a 4 and 5, which is a function called defined in this derived class. So this is how this inheritance works. Let's talk more about this access specifiers. Why this access specifier is important. Now let's understand first the significance of this access specifier. So as we saw, there are three ways this access specifier can be specified. When you specify this as a private, that means all the protected and public members of the base class become a private to this derived classes. Remember, it's a very important point. All the protected and public members becomes a private to this derived class. So in this example, if you specify this as a private, then what happens? All these public and protected members of the base class will become a private to this derived class. That means those members cannot be accessed outside this derived class. So in this case now, if you try to access those members, it will give an error saying this function is inaccessible because it's a private to this derived class. You cannot access outside this derived class. Similarly, it holds true for the protected member functions. And but in case of for the private members which are already private to base, they remains private to this base class. That means they don't becomes a they cannot be accessed outside this base class even if you specify the access specifier as a public here. So this is about the private access specifier in case of derived classes. The next is the protected. When you specify the protected access, all the protected and public members becomes a protected to the derived classes. So again, to explain the example, if you specify the protected keyword here, then if the members are protected, so now this A and B are protected members. Now these protected members will become a protected for this base class or for this derived class. So here you can access those members using the this member functions. We'll talk about this protected access specifier in the next video. And finally is the public access specifier. When you specify the access as a public, all the protected and public members of the base class becomes the protected and a public respectively of the derived class. That means protected members becomes a protected in the derived class and the public members of base class becomes a public in the derived class. So let's again see with the help of this example. So now when we specify this as a public, all this, let's change it to the private, all these public members of the base class becomes a public to the derived class, and that's the reason they can be accessed outside this derived class here to the main function. Similarly, all the private members of this base class similarly all the protected members of this base class becomes a protected to the public to the derived class. That means they can be accessed with the help of this public member functions, but those protected members cannot be accessed outside this derived class. But as we talked, the private members of the base class remains private to the base class. So that means even if you specify public here, they cannot be accessed outside this base class. All right, so we talked about all three different access specifiers in the derived classes. Now let's understand about this third point we discussed. The derived class can be used as a base class for another derived class, creating a multiple inheritance. Let's see how we can create a multiple inheritance. Now in this case, we have created only one derived class and which is derived from this base class. We can create another derived class or multiple derived classes. I will call this as a derived one. Now this derived class can be derived from the base class. And when you do this, it will again inherit all the properties of the base classes similar to this derived class. But in case of a multiple inheritance, when we talk about the multiple inheritance, you can basically derive this class from this derived class. So this derived one class is now derived from this derived class. Now, so for this derived one class, this class derived class act as a base class. So this is how the multiple inheritance is achieved. If you can specify here some different values, and let's change the name. In this case, we have specified this access specifier as a public. That means all the members, all the public members of this base class, or in fact this derived class, becomes a public to this derived one class. That means they can be accessed outside this derived one class even through this main function. And all the protected members becomes a protected to this derived one class. Also, since this derived class is derived from this base class, as we know, this access specifier is a public here. So all these public members of this base class are public to this derived class. Now, since there is a multiple inheritance, all the public members of the base class also become a public to this derived one class because they are public to this derived class. And as we know, since we have specified here public, all the public members of this class will become a public to this derived one class. That means indirectly all these public members of the base class can be accessed through this derived one class. So this is how the multiple inheritance is achieved in the C++ programming. Alright, I hope now you have understood the concept of inheritance in C++ programming. So this is all from this video. Thanks for watching it and stay tuned for the next video.